Yep. All righty, guys. Let's see if I can get my computer to work. It's running real slow. Okay. So looking at this, I just have some made up data of my own that we're going to use. You need to use your data, not my data. You're going to need your graphing calculators. Uh-oh. Yep, I have one that you can borrow today. There you go. All right. So my made up data. (28), 34, and I measured mine in centimeters, by the way. 42, 55, 62.5, 76, 88, and 95. Again, you should use your data from your group. I've just got my made-up data right here so that we can look at what to do with it. Identify the explanatory and the response variables. Let's back up for a second. What are explanatory and response variables? Any thoughts? Yes. Sort of. I like that idea. So the explanatory variable is the one that you think would explain any response that you see. The response variable is reacting to the explanatory variable. So as you're thinking about this, the Barbie bungee jump, you've got rubber bands, that's one of your variables, and then you have distance traveled, that's the other variable. The explanatory variable, if you want to think in terms of algebra, this is your independent variable, this is your x. Your response variable is your dependent variable, your y. So which one of these two, the number of rubber bands or the distance that she traveled, do you think would be the explanatory? Rubber bands. Explanatory variable would be number of rubber bands. And so our response variable would have to be distance traveled. If you measured in centimeters, you should indicate that. If you measured in inches, you should indicate that also. So your explanatory variable, I said this is like your x, this is your input. This is used to predict. Response variable, this is your output. This is the outcome of the study. All right. So how many variables do we have? Two variables. We have an explanatory variable and a response variable. So we have two variables. Are they categorical or quantitative? Both of them or just one of them? Both of them. Both of them, we had numbers associated with those, right? So we have two quantitative variables. All right, I'm going to show you now how to use your graphing calculator to make a scatter plot. And you are going to sketch the scatter plot for your group's data, all right? All right, so I'm going to pull out my handy dandy calculator here. Come on, there we go. I'm going to go to Stat. I'm going to go to Edit. In this first list, L1, I'm going to enter my explanatory variable values. Stat, and then calc. Or sorry, not calc, sorry, stat edit. Stat edit. List 1 gets our explanatory variable values. What was our explanatory variable again? Number of rubber bands. So what am I going to enter down this list? So 0, 1, 2. Come on. Remember, you have to hit enter in between each of these. All right, so from 0 to 7, make sure you actually see 7 show up on the list. And then in list 2, so I'm going to arrow over so that I'm now in list 2. This is where we're going to put the corresponding response variable values. So for 0 rubber bands, how far did it travel? Record that number here. So for mine, I would have 28 centimeters and hit enter. And then 1 rubber band, I had 34 centimeters and enter. Fill this in with all of your response variable, all your distances. Please make sure at the end, every x value, every explanatory variable value, should have a corresponding y value. I would never leave it like this right here. Do you see how there's one more x than y? I need to hit enter. Hopefully it records this now. There we go. Now every x has a y that goes with it. Does everybody have their values entered? All right, so now it's going to make a scatter plot for us. We talked about this very briefly before the chapter 2 test. You're going to hit second and y equals. You guys see how right above the y equals it says stat plot? That's what we're going for. So second and y equals. This right here, if it says plot 1 off, like mine does, whether it says plot 1 on or off, this is what we're going to go into. So I hit enter. Second and y equals. Y equals right up by the screen. Look by your screen. Yep, y equals right up there at the top. Okay, second and y equals. Right now, off is highlighted on mine. I need to turn it on or it won't show me anything. So I'm going to click enter. Yours needs to be highlighted and flashing on. Should look like this. Right. If it has off highlighted, hit enter so that it says on. And it should only be highlighted and flashing over the on. So far, so good? Stat plot. That's this one right here. If that is not the one that is selected, the very first one farthest to the left, that's the one that you want selected. If that's not the one that's selected, then arrow down. Oh, what are you doing? Then you want to make the cursor flash over this and you want to hit enter because you want that first one to be selected. X list, that needs to say L1. Y list needs to say L2. If yours says anything different than that, raise your hand and I'll show you how to get it to say list 1 and list 2. So you want list 1 to be your X's, list 2 to be your Y's. And then we want to make sure that it's zoomed in enough so that we can actually see this scatter plot. We could either set the window, or these calculators have a special way of zooming in specifically for when we do statistical graphs, so we don't have to try to set the window for that. You guys see this zoom button right here up by the screen? Hit zoom. Option number 9, which you might have to scroll to see, says zoom stat. Do you guys see that? Hit zoom stat, so option number 9. And there's your scatter plot. If you do not see a scatter plot on your screen once you hit zoom and then 9, please let me know. You want to sketch your scatter plot that's on your screen. All right, I'm going to make my way around anybody that's having trouble. It gave you an error. Let's see what error it gave you. Syntax. What does it not like? Oh. Try it again, hit zoom 9. Should say L1 and L2. Oh, yours is not set to Scatterplot. It's set on Scatterplot. Oh, okay. Now L1 and L2. Then you do zoom 9. Is anybody not seeing a scatterplot on their screen? You want to sketch your scatterplot. Yes, hit now zoom 9. Okay, so let's figure out what it doesn't like. We're going to make it take us to the error. Yeah, yours has this weird stuff in here. Hit zoom 9 again. Anybody else having trouble getting a scatterplot to show? Okay. All right. Sketch your scatterplot. And when we sketch this scatterplot, we have to make sure to label things. All right, so let's get our labels on here. What is this showing us? Number of rubber bands. And then, do I have the ability to label those little tick marks? How many rubber bands is this one showing me? 0. What about here? 1, 2, 3, 4, 5, 6, and 7. Whatever you have on the x-axis will automatically mean that that is your explanatory variable. What is the y-axis showing us? Distance traveled. And depending on what units you used, you need to write what your units are there. So if you use inches, you want IN. If you use centimeters, mark that as CM. Y-axis is automatically going to be your response variable. We're asked in the last question on this side, number 4, to describe the relationship that's displayed in the scatter plot. So I'm going to pull my screen back up. This is working real slow today. Come on. There we go. Do you guys remember how we had an acronym to remember how to describe a distribution? Does anybody remember what that acronym was? SOX, shape, outliers, center, spread, or variability. When I'm looking at a scatter plot, I have a different acronym to help me remember all the pieces that I need to hit to describe that. And that is DUFs. Anybody in here Simpsons fans? Duff plays a reasonably large part in Simpsons. All right, so the D, this is direction. When we describe the direction, it's either going to be positive, negative, or none. I want you to look at your scatter plot. I'm looking at my scatter plot. How would you describe this direction? As you move from left to right, would that be a positive, negative, or none? Positive. So we have a positive direction or positive relationship. U stands for unusual features. So I don't on my graph, but let's just imagine for a moment that I recorded really wrong and this guy was actually way down here. Do you see how that's way out of the pattern of the rest of them? That would be an unusual feature that I would want to mention. At 6 rubber bands, there was this unusually low distance traveled of 28 centimeters. So there are no unusual features on mine. If you have an unusual feature on yours, you want to talk about it. It would need to be dramatically out of the pattern to count as an unusual feature. F stands for form. Oh, that looks like it says foam. It's supposed to say form. So when I'm talking about form, I'm either going to say that it's linear or I'm going to say that it's nonlinear. When we talk about linear versus nonlinear, if you say it's nonlinear, then you should be able to point to some other shape that you're like, oh, that's like a parabola. That's a U shape. Like it should have a very clear pattern that you would identify. If it's scattered all over the place, we're still going to describe it as a linear pattern. We're just going to say that it's not a very strong linear pattern. And then S down at the bottom, this is the strength. So we have strong, moderate, and weak. So on mine, I would say that that is a pretty strong linear pattern, because while I can't take a straight edge and draw a perfect line through all those points, I see that general linear shape. So if I was asked on the test to describe this distribution, I would say that the scatter plot of number of rubber bands to distance traveled in centimeters shows a strong, positive, linear relationship with no unusual features. Sorry, way down at the bottom. Let me see if I can get that a little higher. There we go. Scatter plot of number of rubber bands to distance traveled in centimeters shows a strong, positive, linear relationship with no unusual features. This is one that I can get away with one sentence as I describe that. Make sure you describe the direction, the form, the strength, and identify any unusual features that it has. So 1 to 2 sentences when you're describing scatter plots. Go ahead and flip to the other side. Big ideas for today, explanatory variable. This is what we're using to make predictions. This is the information that I have. My independent variable, my x. Response variable, this is the outcome. It is responding to the explanatory variable. So as the explanatory variable, the response variable will change because of that. When we describe our relationships, there's that DUFs, direction, positive, negative, or none. What do you think it would look like if there was none? What would it look like? It's going to be all over the place. It's just going to kind of look like dust specks floating in the air, right? All over the place. This one right here, I would describe that as a linear relationship. I would say that's a moderately strong positive linear relationship. I can see, if I squint my eyes a little bit, a fuzzy line shape to it. It's not a perfect line, but I can see how it's going up from left to right. Yes? Mm-hmm. I would still describe that as a strong, positive, linear relationship. If I was to describe this as a nonlinear relationship, I would see a scatter plot something like this. Like that is very clearly nonlinear. That has more of a U shape to it. If it does not have a very clear parabola shape or some other type of function, then we're to describe it as a linear relationship, even if it looks like dots scattered all over the place. I want you guys to try to check your understanding with our last couple minutes. Identify the explanatory and response variables, make a scatter plot and sketch it, and then describe that relationship. Identify the explanatory and response variables. When we're talking about explanatory and response, they have to be quantitative variables. You could never have categories, so words can never be an explanatory variable. Has to be quantitative, something that's described with numbers. Response is the same way. It has to be quantitative. It has to be described with numbers. What do you think the explanatory is? What did you say? I would say screen time, number of minutes. And the response variable would be the rank. So the screen time, the amount of time that it plays for, would be used to explain its ranking. Scatterplot should have come out looking something like this. Does that look very much like a line? Does it look like another specific shape? Then I'm still going to describe it as linear. I would say that this is a negative, weak linear relationship. I see kind of a downward trend to it. It doesn't seem to be going up from left to right. It seems to be going more down from left to right. So weak negative linear relationship with no unusual features.